I'm Anil Kumar. We'll try to understand equivalent rational expressions with the help of this example. The question is, write two expressions equivalent to x plus 1 divided by x squared plus x. Explain your choice. Equivalent expressions, when simplified, should result into exactly same expression, right? So we'll begin with x plus 1 over x squared plus x. You can always factor this. So if you factor, you get x plus 1 divided by x times x plus 1, right? Now from this factor, in the denominator, we can write two restrictions, and these are that x is not equal to 0 and is not equal to minus 1. So these are the two restrictions on the given rational functions. So whenever we are writing equivalent expressions, remember we have to maintain the restrictions. That's very important. So the key here is to include restrictions. Correct. Based on this, let's now write down two equivalent expressions. You can always pause the video, answer the question, and then look into my suggestions. Now as you see here, we have x plus 1 over x times x plus 1. We could always write this as 1 over x with the restriction that x is not equal to 0 and minus 1. So that gives me one example. Do you see that? So that gives me the first one. Now, how do I get the second one? To get the second one, what we can do is, we can introduce something in the numerator, right? We could, right? So what we could do here is, we could say x times x plus 1 divided by, we'll multiply by x both, right? X times x plus 1. Now we introduced x multiplied by x in both numerator and denominator safely, since the restriction was x equals to 0, right? Now consider this as an expression, and we could say we still cancel this. However, we write our expression as equal to x over x squared. Now this is kind of different. Maintaining the restrictions 0 and minus 1 makes it an equivalent expression. So remember, whenever you're simplifying any function, then all the steps in between result into equivalent expressions. So you could introduce new terms, especially in the form of products in both numerator and denominator, and get to the equivalent expressions, right? So that is how we could actually do it. I hope the point is well taken. So we could write our answer as 1 over x squared and x over x squared, where x is not equal to 0 and minus 1. Include both. If you don't, then the only restriction seems to be x not equal to 0, right? I'm Anil Kumar. I hope that helps. Thank you and all the best.